Hi everyone, it's Mrs. Summer here to discuss valence electron trends on the periodic table. The goals for this lesson are to identify the valence electron trends on the periodic table and predict the number of valence electrons based on the atom's location on the periodic table. This method is a lot easier and faster than having to draw the Bohr model for every single atom we're trying to determine the valence electrons for. Valence electrons are in the highest energy level, which can also be the outermost shell. They interact and bond with other atoms. They are the bonding electrons. They are the reason chemistry exists. We found the number of valence electrons by building the Bohr model or looking at electron configuration. So over here with the Bohr model, right here, the valence electrons are the ones on the outermost shell. Starting with the spring 2022 session, we didn't explicitly teach electron configuration. We've removed that from Unit 1. So your only expectation is to know on the Bohr model how to determine valence electrons. The valence electrons using the electron configuration, which probably looks like weird writing to those of you who were not taught explicitly electron configuration. So this will not be required as of spring 2022. There is a much easier way to find the number of valence electrons. All we have to do is look at our periodic table. The periodic table has a trend that determines the number of valence electrons. This version of the periodic table has the Bohr models for several different atoms. If you look closely, you can see that everything in this family has one valence electron. Everything over here will have 7 valence electrons. If you have printed out a copy of your own periodic table, you can label the tops of your periodic table by labeling it in one color: 1, 2, 3, 4, 5, 6, 7, 8. So on my periodic table, purple is equal to valence electrons. So we know that the family, the alkali metals, have 1 valence electron. The alkaline earth metals have 2 valence electrons. And the halogens have 7, and oxygen groups has 6, and the noble gases have 8. Because if you remember, noble gases are completely filled outer shells. Filled. Okay. Your turn to practice. How many valence electrons do the following have? Lithium, potassium, argon, chlorine, and calcium. Lithium is in group 1, so it has 1 valence electron. Potassium is also in group 1, and it has 1 valence electron. Argon is over here. It's a noble gas, so it has 8 valence electrons. Chlorine is a halogen, so it has 7 valence electrons. Calcium is an alkali earth metal, and it has 2 valence electrons. Just want to remind you all that just because this is the basic information, and that you may be required to synthesize this information and apply it to questions that don't directly come up in the Edpuzzle. So making sure that you listened to this Edpuzzle and not just watched it, as well as taking the notes and applying the information and not just regurgitating it.